This video is a brief introduction to Möbius. It's a STEM teaching tool that I'm piloting at my university right now. The problem that I'm showing you is a problem in complex math. It's very introductory. This is one of the first problems that I show to students in my quantum computing class because complex numbers are important there. So this is the student interface for this problem. You can see here I designed this problem to show the students an x variable and a y variable. They're complex variables. And so the first question is, what is the modulus of x? Well, I can enter this in. I can choose my entry mode. So I just press this button down here. It's a sigma sign. I can choose between a text entry or a symbolic entry. So I'm going to use a symbolic entry here. It's nicer to look at, I suppose. So the magnitude or the modulus of x here, it's going to be 4 squared plus 7 squared. So 16 and 49 looks like 65 to me. So I'll put in square root 65. So you can get all sorts of math operators here if you like. There's something raised to the power. Or you can just type them in like a, and then I use a caret, and it gives me a superscript, but that's not what we want right now. So I've entered in an answer, and what I can do now, just to do a progress check, I can ask, well, how did I do? And so if I click how did I do, it shows, hey, look, I got this answer correct. It's square root of 65. There's a help here. My answer matches the correct answer. One thing to note is that you can do anything mathematically equivalent. So if I could do 13 times 5, that's also equivalent to the square root of 65, I believe. And so that ought to work. Or any number of other equivalent mathematical forms, that will be fine. And I can do a similar thing for y. I'll also point out that I have another number here for the angle of x, or the argument of that complex number. Same thing for y and its modulus and argument. One thing to note, students, when you are entering a complex number, you need to use capital I in Möbius. So let's look here. For example, this problem down here asks me to add x and y together. And so let's just do that. In our head, so we're going to have a negative 4 and a negative 8 give us a negative 12 for the real part, and a 7 and 5 give us 12 for the imaginary part. So what I'm going to do is I need to put it in here as 12 plus 12, and I can put I like this. I can click, how did I do? Let's see. Oh, and it says I got it wrong because I forgot the minus sign. So just a thing to point out here is once I get it right, and we'll hover over the answer for a moment here, it says 12 or negative 12 plus 12i, and the correct answer shows as negative 12 plus 12j. So be flexible about how you interpret the answer. I actually left some feedback here, as you can see. It says use I, that's a capital I, for the imaginary unit. So it says for something like J5, enter 5 times capital I, or 5i. So just beware. Möbius kind of expects a capital I for the imaginary unit. And the output, it may be a J or a lowercase I. But watch what happens. I'll put in the lowercase I, and then I'll ask it, how did I do? It really wants that uppercase I. All right, so be aware of that. And that's probably enough for an intro here. So you have to, you can put in the right answer or a mathematically equivalent form. That's beautiful. Use capital I for the imaginary unit. Rely heavily on the how did I do. And once you're done with filling in all the answers, all the response areas, that's when you're going to want to do a how did I do and just double check everything over. And once you're done with that, then you hit the grade button. That submits it for you once you're all done. So that's an intro to a Möbius problem. Now for you instructors out there who are watching or Möbius people, I'd like to point out that this is much, much more powerful than Canvas, right? The closest thing in Canvas to a problem like this is an algorithmic problem. A Canvas algorithmic problem deals with, parameters that it randomizes for different students. And the drawback there is that, well, there are many. One, you can only ask for one answer based on that parameter set. That's it, just one number. And that number is a fixed point number, so that's two drawbacks. Third, it doesn't handle anything symbolic. It can't do things that are mathematically equivalent. Fourth, it doesn't use complex numbers. And look here at Möbius at how it allows me to ask. You can see, look, I'm asking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 different responses for one parameter set. And again, those parameters are the x and the y complex numbers. So I really have this enormous freedom to structure a problem and really make some nice scaffolding to lead the students through a thought process, or to lead them in a way that kind of guides them toward the right answer. All right, and so that's all I wanted to show you in this brief video. I hope that for the students it kind of helps you understand a little bit better how to deal with Möbius. You can sometimes choose whether you want to enter it like text or symbolically. You have the help, right? You have the how did I do, you can see the help. I hope that gets you started using Möbius somewhat successfully. As always, feel free to comment on the video, subscribe to my channel, like the video. Thanks.